Hello, my dear friends. Today we are making the matrix rain effect. So here we can see that how it comes into play. There are different digital raindrops that are falling down, and they have color variations and animations. And it's a very famous effect that we first saw in the movie The Matrix. And I was always very impressed by this effect. And now I'm trying to recreate this. Let's dive into our code. We'll go to Visual Studio uh, and let's start coding in C++. This is here I have a very fresh project. I haven't added any file. I have named this project as Matrix Rain Effect. Now I'm going to just add a new file. So I would add a new item which is C++ file. So here this is my C++ file. So let's start coding. Uh, Before we start, let's make some things clear. I'm using Windows platform, and this is going to be very platform specific, and all the console shenanigans would be in Windows. So please don't complain if you are running on other operating systems. I might recreate this effect later in web or maybe in Linux. So for now, please bear with me. Uh, before uh, before we start, let's see what we need. We also would need some boilerplate code. So let's start by including some Windows libraries. So Windows.h, we would need this library to it would do a lot of work for us. And then we would also include iOS training and names space std. And let me increase the font size. Also, we would need a main function in plain, and we would write some default boilerplate code. So, in order to use Windows library, we have to add some boilerplate code to handle console input, console things. Um, Let me quickly just check everything is working. So, let's compile and run this. And let me share my screen with you. Console. Okay, so here we are, and this is running correctly. Before we start, we have to make set some properties as well. So just right click on it and go to properties. And in order for our matrix program to run properly, we have to make sure that we have these properties set, which should be 180 pixels or characters. Height should be 150 characters, and the window size should match the same. And for font, we need to select uh, either my MS Gothic or Simpson. This font, I would explain why this is important. So just select this font and select the size as 18. So these settings should be with, these settings should be your default settings for console in order to proceed. So now let's get back to coding and let's start writing some code. Here we are. So okay, so first of all, we would need a function. We will call set console buffer. This function would set our console properties for us. Then we would also need another function which would be, we would call update. This function would be this would be running at on each frame. This function would run and make sure that whatever we are our logic is, it is displayed correctly on the console. So these two functions are our main function. So let's remove that. And first function we will call is create, sorry, set console buffer. My better name is create console buffer. Sorry, create screen buffer. So let me quickly add that function. Okay, so let's rename this to create screen buffer and copy this and then paste it here with the name. and then we would also call update function. And I think that should be it. Also, one more function we need is um, initialize matrix. So whatever we want to display in the matrix, we have to initialize this as well. So we would also call that function between create and update. Initialize. So this is our stub or structure. Let's start adding some boilerplate code. So first of all, in order to write, create screen buffer, we need some variables. So we will just copy paste these variables here. And we also need some screen width and height. So as we have already shown that in the console settings, we are going to manage those. And our screen width is 180 characters and our screen height is 50 characters. So this is good for us. Now we would add the code to create a screen buffer. So I would just quickly grab that code and I will try to explain it a little bit. It's not that important because it's just a boilerplate code. This line creates a long character array of which comprises of our screen. As we can see that it's a flat array, so it's just like a one-dimensional array. Rect is basically creating a rectangular area on the screen where we will write our different where we would adjust it and we would this is basically to store the dimension of the screen. So here we have top left corner and bottom right corner, and then we have buffer size. So we are specifying a particular buffer size for our screen. Then we also have an update function. So it's a uh, so let's also write that function quickly. It's a boilerplate code, so I'm not going into too much depth here. And so first of all, we would need to include a few libraries. So first library that we will need to include is chrono. And this library is used to measure high resolution time. And then we would also need string library. This library is used to include different string operations. And we also have a function called clear string, which is a very simple function. So we also let's create this clear string function. This clear screen function basically is called on every frame to clear the screen to uh, blank spaces, so that whenever our next frame is run, we don't see garbage on our screen. So let me quickly write that function. It's very simple. We just have to we have loop over all this the screen array size and set each pixel to be blank space and with the color uh, black. Zero is for black color. So it's a good time to also include the console colors which are available to us. So let's include those colors. And, yeah, we have colors. So we also define one more color, which is black, and its value 0. So here we would just write black. So this is just to make our code look much a bit readable, and that's why we are writing it like this. So we have set our clear screen function. Now we have some things to do. We have to initialize our matrix. So let's think about our matrix structure. What do we need in matrix? So if we think about the matrix, we can think of breaking it down. So this matrix rain effect has on multiple raindrops. So we will focus on one raindrop. So let's make a struct called matrix raindrop. And this structure should have some properties. So first property is next position. And the second property is y position. Why am I making it a float? Because x position is supposed to be horizontal position, but the y position is what where it would be displayed from top to bottom. It has to move as well. So because it is moving, it's better to have floats so that it ensures a smooth movement. And now we would also add text content. There should be a text in this as well, and that text would be those different characters that we see falling down. And also we need one more variable, which is the speed, drop speed. So each drop might have their own different drop speeds. And when we've written this raindrop function, we also need to write one more function, which is initialize raindrop. Because when we create a raindrop, we have to initialize it. It would accept a pointer to matrix raindrop. We'll name it drop. And there are some properties that we need to initialize. Okay, so what's the problem? Okay, let me fix some issues. So we have to initialize a raindrop. So we would just set some properties. So x position for now, x position for now would be 0. Then similarly for y position would also be 0. And for now we would give this drop a drop speed of let's say 10. So it's just an arbitrary number for now, it doesn't matter. Then we would also give the text as this is a double string, which means wide string, and it supports Unicode, so we have to write at the start of the string. So let's give it some familiar text, and this should be our initialize raindrop function. Now we also have to initialize the matrix. So for that, we would define a vector of matrix raindrops called drops. And also we would need to include this library. So we would include this. We would include this vector library here. And so we have included this, and now let's initialize this. So we would, there is also one more thing, one more variable we need to define. We need to define total raindrops. So let's define. So for now, let's define one raindrop, and later we would increase this number. Copy this, and we would run a loop from I equals to 0 to I is and that number and I plus plus. Now we would initialize the total raindrops and add them to our drops array. So first of all, we would see matrix drop. We have created this drop, and now we have to initialize this. Initialize raindrop, and we would pass in this drops address. And when it has been initialized, then we would add to what drops array. So we will write drops dot pushback, and this drop should be added into this vector. Now we have added raindrops. Now let me quickly explain what this update function is doing. Currently, we have a start time. We're just storing the timestamp when the program started. Then we go into this loop and we report the current timestamp. We calculate the difference, and then we resolve into elapsed time. And also we make the start time as the current timestamp. So every time this loop runs, we subtract the time differences, and it essentially gives us the elapsed time between two frames. So this is a very common technique to get elapsed time, and we also can convert this elapsed time into frames per second. So these frames per second help us a lot in performing different logics in game development. So we can use this function. We have clear screen, which we already explained. And now we here, this is our display logic. So we would use auto for loop to resolve this. So from drops, we selected a single drop, and then we have to display that drop. So let's call we have to display character by character. So I'm doing that here. I is less than drop dot text dot size, and then we also have to implement I, and this is our structure. Now we also need to add another function which would we would use to display text on screen. So for that, let me quickly add that function. So let's define that function here. So this is a function create draw vector on screen. It accepts x and y parameter. X and y two parameters. Then it accepts a character, and then it accepts a color. So it simply calculates the index. As our screen is one dimensional, so we have to calculate it based on our y and multiply by screen width, which will calculate the correct offset, y offset, and then we add the x. So it becomes our index, and then we just convert the Unicode character. We accept our new character as Unicode character, and we also give it the color if the color is specified. So we would use this function here, and we would just draw that character. So what do we need here? We need an X position. So X position is in drop X position. Then we also need the Y position. So we would add drop Y position, and we would subtract J from I from it. So this would display the text on the screen, and then we would need a text. So we would say dot text, and we will give it the index of I. And for color, right now we are not giving any color, and by default it would draw a white color. So let's save this and build this, and see if this builds without an error. And let's try to run and see what is the result. Okay, so before we do that, we also have to do one more thing, which is we have to calculate the y position. So as y position, we have the speed. So let's try to simulate that. We have to multiply drop speed into elapsed time. So this would give us new vibration, but we have to be careful about that in here. So we would see that because y can go out of bounds and it will cause error. So we have to be sure that the y position and the text size, we also have the text. So this difference will make sure that when the last character of the text disappears, only then we perform our operation. So if this particular difference is greater than screen height, then we perform, we have to initialize the raindrop, and we would give it the same drop. So it would make sure that whenever this condition occurs, our text has disappeared from the screen, then it is reinitialized. And also we would need to calculate the y position here. because it might give us some error if we are not careful. So we would just calculate it for dot y position minus I. And as we know that this is an integer and the proposition is float, so we will pass it into integer. And now we will pass this position here. But we also have to make sure that this is correct index. So we would check it if this is not in bounds. So let's check that, add that check. So if y is in bounds, only then proceed to draw the corrective. So let's see if this works. Let's compile and run this. Okay, so we have fixed. There was some error. We have to. There was syntax error. So when we are using auto for loop, then we have to provide this as a reference. So now it's fixed. Let's check how this looks. So let's start debugging. And let me share my screen as well. So here we can see that some a raindrop is dropping, and when it goes out of bounds, then it is reinitialized and it comes back again. So this is a very nice achievement so far. Let's get back and let's further enhance this code. Now we have a raindrop. We have a system to display a raindrop, and we can see that raindrop is moving as per our requirement. So let's create more raindrops. So if we increase the raindrop size to suppose 50, let's see how it works. And in order to make sure that these different raindrops are initialized properly, we have to make some changes in our initialize raindrop function. So first of all, we have to make sure that this exposition is now random. So we will add a random function, and we would position it in such a way we would just modulo it by screen width. And this means that this expression will return an integer between 0 and the screen width. So any random horizontal position would be given to x. For y, this is good enough. We also need the drop to start from top. So for drop speed, we have to have define a range. So we will define a range for, for this drop speed. So we would have minimum drop speed, and this is, let's suppose, 5, and then we would have range of drop speed. So this would be suppose this would be as we have this drop speed, the minimum drop speed would be float, and the range would be an integer. So we can have like 40 as range. So we the final range would look like this. Let me quickly add. So first of all, you add minimum drop speed plus random number generator to generate this range. Now, this is a very typical pattern in generating random numbers between a particular range. So we are generating minimum draw speed between 5 and 45. Add this to 40. So this way we can generate any random number between any two numbers. Now we also need to generate the text. And first of all, we have to have a dynamic text range, text length. So let's say minimum text length, and we say that it's 5, and we have to have range of text length, and it's suppose it's 20. I think that would be good enough. So let's make the calculate. Let's get current text length. It would be similar. The minimum text length plus random in modulo range of text length. So it would give us a text length between 5 and 25. And then we have to create the text. So we would say I equals to 0, I is less than current text length, I plus plus. And then we have to get a W character, which is a white character, random character. And it would be, and here we would use the similar technique to generate a random character. And then we would append that character to draw dot text dot append, and we have to append one character, and it would be random character. So let's figure this out, and also we don't need this anymore. So in traditional matrix effect, we have Japanese characters called as katakana. So these katakana characters are not available in default console. That's why in console settings we set the font as N Simpson. So if this function font is not available to you, you can download it online, and it would display the correct Japanese katakana characters. So for the Japanese katakana characters, we already have defined a range and minimum characters. So let me quickly grab that and paste it here. So this particular range shows beautiful Japanese katakana characters which are used in the matrix. So let's use these variables and generate a nice effect. So this range would be here. And now I think our initialized raindrop function is complete. So let's try to visualize this. Let's see how it looks. Let's run this. And let me share my screen with you. So as you can see, these beautiful katakana characters falling down on the screen. So our matrix effect, raindrop effect is kind of 70% complete. We need to think about color, and also let me show the console settings once more. So here we have selected this in Simpson, and font size is 18, and layout we have 180 by 50. So this is very important that you have the same console settings, and then you would be able to see these beautiful katakana characters. Now we can see that these are randomly generated and falling down. So let's get back and let's think about color and styling. So now we have this beautiful katakana characters. Let's give some color to the characters as well. So here we would calculate the color. So let's default it to white. And let's calculate the color based on its position. So the first position is going to be if I equals to 0, then we have to give the color as white. So the first index would be white, as if I is greater than 0 and I is less than equal to 2. So first two characters, they should be gray. Then we also would like to include the speed into color calculation as well. So if I is greater than 2 and draw speed is greater than 20, let's say 20, yes, we would give it green, bright green color. And if we would just use the same condition but reverse it. If I is greater than 2 and draw speed is less than equal to 20, then our color should be bright green. And lastly, default, if, there is the scene, final scene should be clean. So we should also add this color now here. And let's see how this looks. Let's build this. Let's debug this. And let me show my screen. So here we can see this in effect. Our matrix rain is working and we are seeing some different colors. We are seeing white, gray, and green and light green. So this is like 90% complete. We just have to add more raindrops and we also have to talk about one more thing. So let me quickly get back to code and let's talk about one more thing. So in the matrix, there is an additional effect which is called characters in place. So let me show you what I mean. The characters in place effect is when the raindrops are falling down, they tend to look like they are in one place. Let me show that if I can show that in the video. Uh, okay, so here if we can see, and if my recording frame rate is not too low, we can see that when the raindrop is falling, and then the characters are staying in place and they only tend to move when the tail is tail moves. So we have to kind of replicate that effect, which is very important to me. So let's try to figure this out. And let me go to Adobe XD and let's see how this effect looks. So here we can see that this is showing a random raindrop. So it has the index I and it starts from 0 and goes up towards end. This I is of size 8 and we have currently the F position as 50. This position will be updated on each frame. So it would fall down and then at one frame it would be 50, then in another frame it would be 51 and so on. So if we use this formula, I minus F position modulo size. The size is of this particular example. This raindrop is 8. So modulo function is basically like a division function, but it only gives us remainder. It doesn't give us the quotient. We don't care about that. So it's a very powerful function, and we would see its usage in the future videos as well. So for now, if we calculate this, we can see that I minus F position with 0 minus 50 is equal to negative 50, and we give it absolute value, so it would be 50. Then it's modulo with 8. So 50 divided by 8 would be uh, would give us a remainder of 2 as 6 times is 48, so it would give us a remainder of 2. Similarly, if we could perform this calculation here, why it would be subtracted, 1 would be subtracted and the remainder would be 1, then 2 would be subtracted and the remainder would be 0, and so on. So these basically these indexes are stable and they don't change much when they are falling down. So we would use this indexing system to display our characters. So let me quickly add this as well. So here in this calculation, we will also include um, character index, and it would have a value of I minus um, drop dot y position, sorry, drop dot y position modulo drop dot x dot size. Let, let me clean up this expression. First of all, we would need brackets here so that it gives correct result. Then this is the float, so we need to convert it to integer. And also we need to use it absolute value so that there is no negative number. And then we would use this character index here in place of I. So if we do that, we would see a significant improvement in our result. So let's see how this changes our matrix range. So let me share my screen. As you can see that now the raindrops are falling and they don't seem to be changing too much. They are in place. They're falling in place and only change when the tail passes through them. So this is a very nice effect, and we, as we can see that this effect now looks complete. We might want to increase the uh, number of raindrops. So if we increase them, then this effect will be more prominent. So for now, for our purposes, this is pretty much it. This is how you create a matrix range in C and C++. And please subscribe and like the video. And if you want more of this content, please let me know. And thank you for watching. Take care.